Wonderful. Good morning, everyone. Welcome to the exciting webinar on building the future of IoT with battery-free sensors. I'm Mingxi Liu at Energis, and I'll be your moderator for this session. Today, we have the industry thought leaders from both Energis and InPlay. They will share their insights on how combining battery-free sensors with over-the-air wireless power network can revolutionize your business. Before we dive in, just a couple of quick housekeeping items. This webinar is being recorded, so both the slides that we're showing you today and the recording will be shared with you after the event, so you don't need to jot down anything. So if you have any questions during the presentation, please type them into the Q&A or the chat box. We'll try to address them as much as we can during the Q&A session after. Now, without further ado, I will start introduce our esteemed speakers. First, we have Gianpaolo Marino, Senior Vice President of Strategy, Marketing, and Business Development at Energis. And from InPlay, we have Serge Stefanian, Senior Business Development Manager, and Aidan Martins, Field Application Engineer. Now, I'll pass the baton to the speakers for self-introduction. Thank you.
Hey, thank you, Mingxi. Thank you very much. First of all, good morning, everyone. Good evening if you're actually calling from Europe. So my name is Gianpaolo Marino. I am the Senior Vice President of Strategy, Marketing, and Business Development at Energis. So Energis is a systems semiconductor company that has really pioneered a scalable over-the-air wireless power network solution with the goal to really enable the next level of visibility, with the goal to really deliver what we call real-time supply chain, and again an intelligent automation for IoT application. And I will unpack that a little bit more into the details as we go through this presentation today. Next.
All right, I'll start then. I'm Aidan Martins. I'm a Field Applications Engineer at InPlay. I'll be speaking in this presentation a little bit about the IN100, that's the InPlay BLE beacon. And I'm also the main point of technical support for this device, so you'll be reaching out to me afterwards if you have a question on the InPlay parts. And then the Serge.
Hello, everyone. Good morning, good afternoon, good evening for all the attendees. Thank you so much for attending. My name is Serge Stepanian. I'm with InPlay Technologies with several years of experience in the semiconductor sales and engineering. InPlay Technologies is a leader in wireless SoC chips, which we specialize in fields of logistics, transportation, medical, gaming. So today, our focus is going to be on our logistics and asset tracking market, along with our great partner Energis, and we look forward to presenting our combined solution, which is also going to be shown at the Sensors Converge show in less than a month in Santa Clara. If anyone is attending, we would love to have you stop by and see all of us. So with that, I think we will dive into the webinar. Thank you.
Great. So as far as the agenda for today, we're going to cover several interesting topics that have got to do with battery-free or battery-less BLE-based sensor solution. The first one is obviously a digital transformation, a new world of IoT. We will unpack what digital transformation means, what are the trends that are driving basically this technology, this digital revolution across asset tracking and logistic application. Then we will discuss deployment challenges, that we have seen, especially working very closely with some of the biggest retailers in the world, as well as the logistic company. We will talk about the future of IoT from our standpoint, which is Energis, which is basically really unleashing the full potential of wireless power networks. We will touch upon battery-free sensors and what they are and why we believe in this new class of sensors hitting the market. Then Aidan and Serge will talk about InPlay Bluetooth SoC and how this really technology is revolutionizing a lot of the application around Bluetooth especially in asset tracking and supply chain. Last but not least, we'll touch upon Energis wireless power network solution. We'll discuss a few of the use cases that we have already been involved with our partners and the intricacy of it. And then we'll take the last probably 5 to 10 minutes to answer any questions. Great. So let me start by saying, digital transformation is really painting a new world of IoT. This trend is affecting all aspects of supply chain application. Real-time quality control solutions, again, are needed to ensure safety across different market segments. If we look at some of the challenges that are affecting many applications, especially in retail or logistic, what we hear over and over and over is, again, product diversion, cargo theft and fraud, traceability compliance. Again, if we are talking about supply chain or cold chain, spoilage, food waste, supply chain, disruption. So, I mean, these things right here are actually some very, very strong pain points that are coming across a lot of the discussion that we're having with many customers. And so if I had to quantify that in terms of how much revenue, customers are losing every year due to, today's challenges, I would say anywhere between $5 to $10 million a year, which is a huge number, right? So we see a lot of this company today, a lot of the company that we've been talking to, investing into supply chain visibility. I want to be able to really track my product journey, across the entire supply chain. And I want to know exactly where my product or where my asset is at any time, at any day, right? Transportation management, right? How do I basically get to manage now, my operation now that I have created a digital twin of it? Data management, which is extremely important. Now that I'm basically deploying all these sensors and I'm collecting all this great data, what do I do with it? How do I create alerts? How do I massage the data in such a way where I can improve my operational efficiency that I have been discussing? And last but not least is real-time IoT trackers, right? And this is for us is basically, this new category, this new level of IoT devices, of sensors, that we're seeing, hit in the market over the next 2 to 3 years. So let's start with the biggest pain point in the room. I kind of want to really, focus on the elephant in the room here, is that disposable batteries are expensive. Okay, so we know that today, disposable battery represent almost half of the cost of the IoT device. Okay, so when you talk about, again, maintaining the battery, the battery itself, it's very costly. Sorry. Mengshi, you might want to go back. Thank you. So the second problem of the battery is that they represent a limited energy storage, right? So it's a constraint for designers, to really design their circuit, their IoT circuit, when you have, again, battery constraint on the power side, right? So if I want to introduce new feature, for instance, if I want to start doing processing at the edge, right, by eliminating latency, by making my sensors, my IoT device a lot more smarter, I have to increase the battery size, and increasing the battery size, then I have to increase cost, right? So this represents a scalability problem. I talked about processing at the edge, which is a distant dream, because again, it requires processing power, and processing power requires bigger battery, and bigger battery, again, bigger IoT devices, bigger sensors. It really goes against this idea of scaling. And last but not least is maintenance-free sensor. By eliminating the battery, we're enabling customers to really reduce cost on maintaining those sensors. Batteries are unpredictable. We don't know when they're going to basically go to zero. Some battery might decay in a year, other battery might decay in 1.5 years. And that level of unpredictability really adds on the cost of servicing those batteries. So we want to just eliminate all that, because, we think that by doing so, we can really enable, this new class of sensors, to scale from the hundreds of millions into the billions. So there is other challenges, of course, beyond, just the battery that we see in the market today. The first one is wires and cables. Again, higher installation costs. I mean, you have to run cables, through shelves, gondola, through basically infrastructure and warehouses. It adds cost. Also, cable represent location limitation and limited mobility. If I have cable running through my sensors, I cannot place these sensors, everywhere because, again, my mobility, it's limited. And again, they present also some safety hazard. Let's not even talk about sustainability, which is also a bigger problem. Today, and this is a fact, okay, there is about 100 batteries, disposable batteries, that are reaching landfill every second. Multiply that by 24 hours, 360 days in the year, and you will quickly come up with a number that is in the billion, okay? Billions of disposable battery reaching landfill every year. That's an issue. It's an issue because these batteries are toxic. They're wasteful. They present landfill issues. They are safety hazard. And we have heard and we have read that the European Union is planning to ban disposable battery for this exactly reason as of 2027. Last part is the data latency, right? Again, what we are seeing today is that every IoT sensor, every IoT device wants to have its own way to communicate, to the cloud. Well, this actually represents a little bit of an issue because there is data overload. Then there is an aspect of latency. As I mentioned before, unless we start doing processing at the edge, the latency issue is always going to be there. So in application where you have prevention and maintenance, where you have sensors that really need to be able to respond to an event in microsecond, that could be a problem, right? So again, for us, these are some of the deployment challenges that are affecting this new world of IoT today. And so if we can eliminate those, then I think we can really scale these devices, as I mentioned, in the billions of units. So let's talk a little bit about the market. So there's two categories in the market, especially for asset tracking, logistics, supply chain application, two categories of what we call digital triggers. Why digital triggers? Because these IoT devices, depending on how they're used, are digitizing basically the operation of the customer, right? So the idea here is to create a digital twin of a customer operation so that we can address operational inefficiency and really enable customers to save millions of dollars every year. So there's two categories. The first one is RF tags, which is huge, right? So we talk about UHF RFID. We also talk about, for instance, low power BLE tags such as Wiliot. These market represent what we call ambient IoT, and is a market that is growing tremendously over the next few years, really into the trillion. Then the second market is IoT sensors. And when I talk about IoT sensor here, our focus is primarily on BLE-based sensors, which today, are really, it's a category of sensor that is growing tremendously. It's estimated that in 2024, there should be about 150 million BLE-based sensors that are going to be shipped. And that number is growing to about 260 million in 2026. So these are the two categories of devices, that we always talk about when we focus on the market. So before we dive into the details, what does the supply chain journey represent? So where are these sensors, where are these tags, strategically placed across, the supply chain? Well, first of all, a digital ID needs to be created for each asset. This is when you start basically pairing your sensor or your tag, with a specific asset that you want to track. And that typically happens, during I would say, the initial part of the product journey, right? You are in a warehouse, you're ready to basically ship the asset, to a store. That's where you basically create your digital ID. The second part is obviously when the asset is actually it gets loaded onto a truck or a transportation vehicles, right? So again, asset loaded for delivery, providing real-time data and location. Then we also have real-time monitoring of asset during transportation before the asset is actually delivered to the store. Then the asset is actually delivered to the store, providing real-time data on location. And last but not least, which is the last part of the journey, is when the asset is stocked on a shelf, right? Providing real-time visibility into location, temperature, whatever that asset is. It's actually very, very important, to continue to transmit information, because that will give customers, let's say a retailer, for instance, the ability to understand whether or not an asset is sitting on the shelf or it's not. So how do we really get, to a digital transformation? How do we get, to this concept of real-time supply chain that everyone talks about it? But again, for a lot of the customers out there, it's still a far dream. Well, for us, what it is important is the need to have a reliable, scalable, wireless power solution. And let me unpack that and go into the details of why. Well, first of all, we need to basically provide on-demand access to wireless power, right? And that is basically similar to how cell phones today, provide seamless access to data from anywhere. We need to ensure that devices that are operating without batteries and they're harvesting technology off of, wireless power are able to stay powered 24 hours a day, 7 days a week, 365 days a year with no downtime. These will in turn really help improve operational efficiency, because now with these assets transmitting data, constantly, we get accurate, real-time, and actionable data communication, right? And we're start getting into automated flow, to optimize, device performance. Also, having a reliable, scalable wireless power solution helps to reduce costs, because now we're eliminating the needs for disposable batteries. We're eliminating the needs for wires and cables, and we're also eliminating the needs for maintenance costs. And that is huge, especially for a lot of customers that are out there. And again, cost is the biggest barrier. If I can eliminate cost, then I can start scaling these sensors, again, into the billions of devices. Last but not least is to provide network flexibility and mobility, right? Network that is able to scale, with IoT application. And whether or not we talk about real-time or retail, whether or not we talk about logistic application, we want to make sure that the networks is flexible and scalable. So how do we see the future of IoT from our lenses? Our lenses is obviously wireless power network at a distance. Well, the way we see it, it's very simple, right? You have a bunch of sensor solution or IoT sensor devices, at the bottom as a first layer. These are all basically harvesting energy, from our wireless power network solution, which is what Energous is focusing and is building today. Okay, and so think of it: temperature and humidity sensor. Think of CO2 sensor, light spectrum, security sensor, pressure, prevention and maintenance, positioning sensors, all the way to optical. The ability to harvest this energy that is coming off of Energous wireless power network, right? And be able to operate now, without the constraint that batteries, cables, and maintenance are basically affecting today. Then we also see sensors being able to communicate through Bluetooth technology back to our transmitters. And our transmitters, our network of transmitters, basically pushing data into the cloud, either through a Wi-Fi access point or through basically a VLAN access point. That's really the way we see, IoT reaching, billions of devices in the future, for us. So how does this work? This is a very high-level network topology. So again, I mentioned a high-level view of what the network looks like. Well, but what does it happen now between the transmitter and the sensors and the receiver? Well, basically, the transmitter energizes the sensors at about 900 megahertz. right? And the sensor, is capable of doing energy harvesting at the same band. And then there is a communication, of an exchange of data between the sensor and the transmitter, which happens over Bluetooth. The transmitter basically takes that data and push the data into the cloud, through a gateway, through basically an existing access point that we see common every time we work with, again, big retailers, big logistic companies. So from a block diagram, getting a little bit more into the details, today Energous has 3 families of transmitters, 1 watt, 2 watt, and 1 watt omnidirectional. And when you open the hood of these transmitters, you typically see a Bluetooth chip that is able to, again, to leverage data and push data, into the cloud. But then you also see Energous transmitters and Energous PA inside. And this is really what it is unique about us, is the ability to be a system semiconductor company. Not only we design system on the network side, but we also have the ability to design our own semiconductor. And that, again, gives us a lot of uniqueness. As a company, a lot of flexibility also when it comes down to regulatory approval in many countries around the world. Energous today is has regulatory approval in over 122 countries. On the receiving end, which is basically the IoT sensors, you basically will see a receiving antenna that is capable of harvesting energies, a diode, for rectification. And then you see basically, that voltage and current being pushed into an harvester, which is basically EPs, our partner EPs, PMIC, and then scaling that voltage and current, to feed the right level of information into a sensors, and obviously, keeping the in-play Bluetooth chip alive and able to communicate back to the transmitter. So I quickly mentioned about our Energous 1 watt power bridge. This is our first generation power bridge that we have developed and we have available. Some of the key features are, again, 2.4 gigahertz energizing signal. We have sub 1 gigahertz energizing signal. We have a BLE beacon for communication. This is a dual polarized sub 1 gigahertz and 2.4 gigahertz antenna to energize with more power. 5 volts operation via USB-C. And we do also have an external antenna option, which is our omnidirectional solution. This is our Energous 2 watt power bridge. This is the new addition to our family of power bridge. We are super excited about this product because it's really enabling longer range when it comes down, distance between the transmitter and the receiver. We actually get up to about 33 dBm at 918 megahertz of energizing signal. We get up to 20 dBm at 2.4 gigahertz. This is really the best device right now in the market, and there is not much to it. It's got a circular polarized antenna, 918 megahertz and 2.4 gigahertz antenna. And it will basically take a 5 volts 2 amp input, and we have several options available, including PoE. And now I'm going to switch over to Aidan to talk about in-play and its technology.
Thank you, Gianpaolo. All right, so just to talk about the in-play role in this is we have the Nano Beacon, or also known as the Ion 100. This is that BLE transmit device that was inside of those IoT sensor tags from Energous. And so what's special about this device, it is one of the world's first only Bluetooth Low Energy 5.3 BLE beacons that is ultra low cost, ultra low power, has this wide energy operating voltage range, and has all of these security features at once. So as Gianpaolo was explaining, there's this passive RFID market. This is a device that's very special in that it targets very specifically that active RFID market. So if we go to the next slide, I can explain about some of the features. So on the right there, you can see this is inside of one of those Energous IoT sensor tags. It has the Ion 100. And as Gianpaolo was explaining, it has the the E-piece parts and then the receiver for the RF power. And then this Ion 100 device can interface with all the system, get that power, and also talk to all of the sensor devices inside of there. And, with a super cap, rechargeable battery, something like that to store a little bit of charge, it can go for quite a long time before one of those Energis transmitters has to power it back up. So this allows for that sort of ease of integration into those existing systems. The Ion 100 just being able to receive this power, switch out the sensor, and you get all this new information. Okay. It also has a very, thank you. It also has a very low cost of different parts, a very low EBOM, right? So all we need is a external crystal, and then maybe a couple caps, maybe a resistor on that voltage line, and you can get the Ion 100 working perfectly fine. That operating voltage range I mentioned before is 1.1 volts to 3.6 volts. So you can see it can work off of a very small amount of voltage being received by that transmitter. Security features, it uses a encryption engine that is AES in EAX mode, which allows you to encrypt your data so you don't have to worry about anybody being able to sniff this beacon and just say, okay, cool, I got all your data. Nope, not going to be possible. And then I'm going to talk about the sensor interfaces as well. We got I2C, very common one, ADC, and then a pulse counter interface, and then also access to the GPIOs, say for like triggered events. Okay, next slide. Okay, so you might be thinking, well, okay, this is a TX only device. Does that mean it's going to be, very limited? And not quite. So we actually have a lot of application examples that we find ourselves being used in. So we can see on the right here, some very interesting ones, for example, would be livestock tracking. We have some customers who will put our BLE beacon inside of an ear tag for like a cow, a pig, animal, and it will report its body temperature to some sort of gateway nearby. So you can imagine a very similar situation with the Energis transmitter, where say these cattle or animals go up to some sort of feeding pen, they get energized, and then you can see, okay, what's their body temperature? Are they getting sick? Also see very many medical applications with this for tracking patients, employees inside of hospitals, or even just people, employees in, generic use cases as well. Property assets is a very big one as well, cold chain as well, sort of tracking all these different devices, as they travel to one warehouse to the other, or within the warehouse itself. So you have some sort of gateway, Energis transmitter that's going to receive and then get that information up to the cloud. And then you have that live information from those beacons. And we also have very many sensors that we work with. As I mentioned before, I2C and ADC opens up a lot of different options. So we have temperature, motion, humidity. Those can be used for different sort of thresholds as well. So cold chain, you imagine you want to make sure your device isn't getting too hot or too cold. You can go ahead and slap a temperature sensor on there. You don't want it being too humid. An accelerometer, you want to make sure something's not being moved around too much as well. And of course, all of this low power capability with the sensors makes it ideal for these sort of power RF energy harvesting solutions. Okay, next slide, if we will. Okay, I'm going to give a very high-level overview of the Ion 100 configuration tool. So as I might have not mentioned before, here, let me go ahead and share my screen for everybody to see. All right. Is my screen sharing properly? It looks like it is. Okay. So as I might have mentioned before, this device is completely code-free. So this means you don't need any firmware engineer, no software engineering to be able to get this working. Anybody can go ahead and download this GUI onto your computer, onto your laptop, change up the settings, and be able to get something working within a couple of minutes. And so this allows you to cut down the costs of development by quite a bit. So we have a development kit that comes with this. I'm going to try to show this briefly on my camera. We have these three BLE beacon boards and then a programmer board that allows you to connect to USB to UART, any sort of cable like that up to your computer and begin configuring with this device. So I'm just going to go brief overview of some of the settings that we have here. So we have these three advertising sets. I'm going to go ahead and show how you might make an iBeacon with this. So you just pick the iBeacon option. You open up the settings. You can choose your UID, your major, minor, and measure TX power level. For example, I'm just going to put in a couple arbitrary values in there. There we go. And so now I have my iBeacon. I'm going to connect to my device. Click the run in RAM mode. There we go. And in say about 30 seconds, I have a working iBeacon. So very impressive with the flexibility and the ease of use of this device. Some other options we also have is we support Eddystone, and we have these custom beacons, which allows the customer to define their own payload definition. So for example, if you go ahead and choose one of these options here, you see how we have this drop-down menu, which has a lot of the sensors and a lot of the internal information from the i100. So this is where you can put your I2C data, your ADC data, how many times the device is advertised, its internal temperature, how much voltage it's currently operating at. So it allows you to have a lot of flexibility. And you can put that in any order you want. Say for this, for example, so you have some sort of voltage, then you have your pulse counter information, then you can encrypt information as well. So let's say I want to encrypt my sensor information, and then you can move that around in any sort of order you want. So it allows a lot of flexibility of how you want to define your use case here. Okay, and then one or two more things before I hand it back to Gianpaolo is I'm going to show how you might have a triggered option. So imagine you have a device that is connected to a sensor, an accelerometer, for example, and when you want it to beacon when the accelerometer moves too much, that you can have this sensor source, for example. So we have these trigger sources and GPIOs. So let's say the sensor sends an interrupt onto one of those GPIO pins. That's as simple as choosing that GPIO pin here in this section. And if you want it to trigger off of that I2C data, for example, we have this sensor trigger source option where you can have a low and a high threshold, which you can configure for that. Okay. All right. And if you want to learn more about this, of course, we have plenty of more resources online. And with that, for now, I will hand it back over to Gianpaolo and the rest of the Energis team to continue the webinar.
Thank you, Aiden. So I think it's very clear that this concept of battery-free sensor is not a concept. It's actually something that we have built, with our partner InPlay. And as Serge mentioned, we are going to be at the Sensor Converge show. So if you are happening to attend the show, please stop by either our booth or InPlay booth to really see how this technology is working live. And it's fantastic to see. We also at Energis offer a dashboard that enables to really bring everything together. So we have a dashboard that we make available for our end customers that gives them high level of visibility on now how these assets that are being tracked are moving across their supply chain. Our dashboard enables to basically detect temperature events, humidity, location, and also provide alerts in case there is problems that all sorts of problems that, or all sorts of alerts that customer wants to build into the dashboard that is related to their operation. So we're excited about that because the dashboard really takes everything and puts it together under the fingertips of our customers, for them to really evaluate how things are moving and how things are basically performing. Okay, so moving on into some of the use cases, this is just, I wanted to give a quick overview of some of the use cases that we have been involved and we're focusing today. But before I dwell into that, this is a very high level overview of how we see basically this wireless power network solution being deployed across many different type of applications. So at the bottom, which is always the bottom layer, you have a bunch of IoT devices, whether that is sensors, whether that is tags, whether it is electronic shelf labels or digital information display. They're basically getting energized by our wireless power network solution provided by Energis. Then there is communication data that goes from the device itself to the network, and then the network pushes the data into the cloud through access point. So very simple way, but again very efficient way and very scalable way in our opinion to really provide this next level of IoT. Next. So we have seen a lot of interesting application, for instance, in controlled environment agriculture, where or what we call it vertical farming, where there is a variety of sensors being used here, CO2 sensors, light spectrum, temperature and humidity sensors. As you can see from the picture below, there is lots of different shelves, there is lots of cables, there's lots of sensors being deployed. And so, we are seeing these as a really unique use case where we walk in and suddenly start saving customers up to 45% total cost of ownership by just switching to battery-less or battery-free sensor solution, with our network on top to charge and keep these sensors alive. Same thing also in a retail environment, where we are now seeing product being tagged, with RF tags, Williot in this specific case, but we also see electronic shelf labels, being able to detect whether or not customers are walking through the shelf, whether or not products are leaving the shelf and they're getting bought, giving customers accessibility, to basically check out a product at the shelf. So we do see as a very, very a unique use case where our wireless power network technology is there, to enable, all these level of automation. Factory automation is, again, another interesting use case where, we're seeing a lot of traction as well. Where again, an ability to really improve operational efficiencies, ability to deploy more and more sensors, to measure temperature, location, humidity, accelerometers, prevention and maintenance, right? So automation is all over the map as we get into this digital transformation. But unless we deploy sensors and multiple sensors, we're never going to get there. And we do see this as a tremendous use case where we can go in and help, customers achieve basically this goal. Smart warehouses, again, logistic application, supply chain application. We see a lot of temperature, location, humidity, light sensors, being deployed. Even here, again, lots of inefficiencies. Customers need to understand, what products are, how products are traveling across their supply chain, how long a product is sitting in a shelf, how long a product is sitting in a staging area, pre-staging area, how long does it take for that product to be on a trailer, and how long would it take the trailer to basically deliver the product to the store. So all these great use cases are incredible, unique use cases that we're focusing on today, where we're seeing major traction. So we're almost getting to the end of these. So we strongly believe that the future of IoT, it's basically going to be enabled by battery-free sensors. This is a $30 billion market of opportunity with a 9.4% CAGR. So the market is there and the market is growing. And we believe that by eliminating batteries, eliminating friction and restriction, we can actually grow this market even more. BLE-based sensors are growing to about 260 million units being shipped as 2027. And our goal is to double this number. And how we do this, again, by eliminating the friction and constraint that today IoT devices have, which is batteries. The benefit of digital transformation to real-time shipping and visibility is so tangible that customers can't deny it. As I mentioned, on the average, and we have had over, I would say, 35 POC with leading customers everywhere in Europe and in the United States. On the average, we know that customers are losing $5 to $10 million a year due to their inefficient way to track devices or track assets across their supply chain. Energous wireless powered network solution accelerate the path to digital transformation, and we do so by enabling this new class of battery-free sensors. And last but not least, again, this new class of devices, this new class of battery-free sensors are going to provide great benefit to customers by cutting costs and reducing power budget dependency. So it's a win-win, for us, it's a win-win for you. I'm sure some of you guys are developing sensor itself, and it's a win-win for your end customers. So this, I believe, is the last slide. Again, find out what wireless power network can do for you. We do have availability and accessibility to quickly evaluate, our technology on a small scale. We do have some evaluation kits that are available for sale, where customers can start really testing and understanding the performance level of this technology. So let us know. We will be happy to support you if there is any specific interest.
All right. Thank you both for these incredible insights. Now, let's move on to the questions, Q&A sessions. We've received some great questions, quite a few of them. I will start from the top. I think the first one is for Gianpaolo. Is there any risks in using the 2-watt power bridge? Is it FCC compliant? It's a great question.
Yeah, this is a really great question. So everything we do at Energis is driven also by regulatory compliance. So if we are introducing a new product in the market, that means that that product meets, the FCC specification and is fully compliant. So we're not introducing product that are not getting FCC certification. That's not our goal. That's not what we do. Everything we do is FCC compliant. So to answer your question, yes, the 2-watt is safe.
Yeah, that's a question that is quite burning that everyone wants to know. That's a great answer. Thank you, Gianpaolo. Another one for you. 918 megahertz is for the US, isn't it? What about for Europe?
Yeah, 918 megahertz covers US, also covers, some areas of Europe, but there are some countries in Europe that are operating at a lower band. We believe around 865 megahertz. So we do have options. We do have SKUs that are able to basically propagate power at that basically level. So yes, we're fully aware of that. And we do have a solution for some countries in Europe, like for instance, Germany. There is I believe Romania. There's a few countries in Europe that are operating, Poland, that are operating at a lower band. So we are able to reduce, that frequency to meet their requirements.
Great, thank you. I believe next one is for the in-play team. EBOM example for this specific module. What do you have? So what kind of examples do you have? And how much does it cost for a healthcare application?
Yeah, so for an EBOM, as I mentioned before, it's actually quite low. So you might have the IN100 BLE beacon. You'll have a capacitor or two, and then an external quartz crystal for the oscillation for the clock for the device. And if you're talking about the total BOM for the cost inside of the Energis tag, that's also gonna, also have more parts in it, all the Energis parts, and then our ePiece partner parts in there as well. For medical applications, you'll probably have like a sensor on there as well. So just to talk about cost briefly, for just a very generic beacon, we've had people be able to sell these at volume, say at like $1 to $2. If you're adding a sensor on there, you're still around that $2 range as well for a simple BLE sensor beacon.
Wonderful, thank you, Nathan.
And I want to add here, and remember, right? The advantage of what we're building here is elimination of the battery, elimination of maintaining the battery, which represents 50% cost saving. So exactly. That's huge. That's huge right there, guys. I mean, this is a tremendous saving that we bring to the table by just eliminating these two features or these two components, battery and the maintenance cost.
Thank you both. The next question, what are the typical working distances for the sensors from the transmitters?
Yeah, that's a great question. Typically today we see about 5 meters with our 1 watt omnidirectional power bridge, and we see up to probably an increase up to 8 meters with our 2 watt power bridge. And let me also explain, this is not a one-to-one. One transmitter energized multiple sensors, right? So in that line of sight, you can put 10, 15, 20, 30 sensors, right? They will all get energized. But again, to answer your question, 5 meter, okay, with the 1 watt, and up to 8 meters with the 2 watt.
Perfect, thank you. I hope that answers your question. The next one, any specific router needed to be onboarded, or any of the existing ones that are already deployed will work with this architecture? This potential client, they do have the WPA 2/3 enable ones. In that case, how does it can be agnostic to the ecosystem?
Absolutely. You can be agnostic to the ecosystem as long as you have BLE enabled gateway, this solution will work. Okay. This is a plug and play, very modular, guys. There's nothing that is going to disrupt an existing network that you might have, an existing infrastructure. These will plug right into it as long as you have BLE enabled gateway. And if you don't, then we can provide those.
Wonderful, thank you. I think this is another question already answered earlier, but I think it doesn't hurt.
Let me unpack this a little bit, because I think this is important, right? Because you talk about 2 watt power bridge. Is there a risk on humans and animals? You guys see that? This is an iPhone. This iPhone in your pocket radiates 5 times as much, okay, SAR level, okay, than the 2 watt power bridge. Okay, so now imagine you're standing at a distance from this 2 watt power bridge and you're getting basically milliwatts, type of power level. This is nothing compared what this guy can do into your pocket. Okay.
Yeah, I actually remember one of our regulatory team members mentioned he'd rather have a room ceiling full of our transmitters than a phone next to his head. So that hopefully put things into perspective. So the next question, I don't know exact regulations in the EU, but plus 33 dBm seems a lot.
Yeah, so I will address this. So yes, the 2 watt power bridge, 33 dBm is basically the 2 watt power bridge. So right now, what we have in Europe is regulatory certification for 1 watt. Okay, let me repeat. We have European certification for our 1 watt. The 2 watt, it's going to be in the process of getting certified. So it's not certified yet in Europe. Okay, but we feel very comfortable that we will meet that certification criteria because it's just an extension of the 1 watt device. Okay, and also we know that the max allowed in Europe is basically on an 865 band is 2 watt, and the max allowed on a 918 megahertz is 4 watt. So we're well within that band.
Perfect, thank you. Another request, can you talk about interoperability? Are there any standards?
Yeah, so there is not this is not a close compliant type of network. This is an open network. The standards, obviously, we are part of the Air Fuel Alliance, and so if customers are interested in building wireless power network solution, we will advise to follow the direction of the Air Fuel Alliance, which we are part of. But in terms of interoperability, we use Bluetooth for communication. So this is an open standard. There is nothing proprietary about it.
Perfect, thank you. What kind of distance can be typically covered by the power bridge and the sensor?
Yeah, I will repeat. 1 watt power bridge, 5 meters. 2 watt power bridge, up to 8 meters.
Wonderful. The next question is for the in-play team. How to receive the energy of the power bridge in IN100 device?
So for the IN100 device, we have our partner ePiece for the the energy management system, the PIC, and then we also have the Energis RF energy receiver that would be there to receive the power from the bridge at those distances Giampaolo just mentioned.
And I think, Mengshi, there is a question from Ketan. Will this power 865 megahertz tags? And I want to address that real quick. Well, if by tag, you mean the sensor, yes. I mean, like I mentioned, we do have a way to throttle back the frequency from 915 to 865. So for countries that are operating off of this band, we can certainly be able to power.
Perfect. I think we have another maximum distance questions again. What is the maximum distance supported for batteryless tags using PowerBridge 1 watt and 2 watt?
Yeah, I think we answered that. Come to the Sensor Converge show and come and see how this technology really works live. That will give you a great idea on the distance. But again, 5 meters, 1 watt, 8 meters, 2 watt.
Cool. What about devices? I think what he meant is, what about other devices? Does it just work for sensors?
It works just for about anything that can use energy harvesting off of our technology. As I mentioned also, we also use pixel tags, which is a Wiliot enabled technology, which is part of the ambient IoT. So I mean, we're not just targeting sensor. Sensor is a subset of what we're targeting here, but there is a bigger market that we're focusing on it. And our goal is really enable customers like you who are hopefully building these IoT devices, to basically employ energy harvesting and enable your device to operate without batteries and without human intervention.
Great, thank you. One more question. How about interferences in a factory environment? Also interested to know, how about the security? Do you have OTA for BLE beacons?
Yeah, so for interferences, or I suppose, Gianpaolo, you could answer the Energis part of this, but I'll just talk about the BLE parts briefly. So yeah, for security for the BLE beacons, we use AES encryption, a very common encryption standard. And we also have some demo code and a demo GUI that we can share with interested people, which shows how the decryption works for that as well. And I can also go ahead and answer more options. And then for over the air for the BLE beacons, the beacon is a transmit only device, so there's no connection, but we do have options to avoid collisions. For example, we have constant tone extension if you have some sort of angle of arrival setups somewhere. And we also have these random delays we can add to make sure that the beacons aren't all talking at the same time. So there's a lot of strategies to minimize any collisions.
Anything to
Yeah,
add,
so
Gianpaolo?
I just want to add that, yeah, do you have OTA for BLE beacons? Of course, I mean, BLE beacons are part of the category of devices that we enable. So we do have obviously a solution for that. As a matter of fact, we're working with a leading customer in Europe right now on a BLE beacon, and we will have that hopefully to market over the next few months.
Wonderful, thank you. Any demo kits available for energy harvesting?
Yes, we do. Please reach out. We have some contacts. If you guys are interested in quickly evaluating this technology, we do have demo kits available that will enable you to do energy harvesting only. Or if you want to have a complete sensor solution, we do have that as well. I believe we have temperature and humidity sensors and CO2 sensors that we ship as well.
Correct. The post-event email will include a link to check out our demo kits or evaluation kits. Thank you for your interest. We're seeing more questions coming through. We have only 3 minutes to go. Let's get through them as much as we can. The power bridge shown in the slides was in the ceiling. What is the aperture angle for the coverage so that we can estimate the coverage area? Great question.
Yeah, that's a great question. So typically it's for the 1 watt is around 80 degree for the directional power bridge, right? So it's about 80 degree aperture. For the omnidirectional 1 watt power bridge, it's basically 365 degrees. And I would say that for the 2 watt power bridge, it's also around 80 degrees directional.
Wonderful, thank you. The next one, on 2.4 gigahertz, how do you avoid interference, Wi-Fi and Zigbee and Thread?
Yeah, we have, we've had multiple POC over like, 35, 40 POC, I can't recall. And we've never had any type of interference issue. And the reason why is because we stay well below, the 2.4 gigahertz band, whether there is Wi-Fi and Zigbee. So, we don't cause any type of interference.
Wonderful. Next question. What is the quickest BLE advertising frequency for the sensor?
Yeah, so the fastest BLE advertising frequency is about 20 milliseconds. So that's also on 3 different advertising channels, right? So that'd be every 20 milliseconds, you get 3 different advertisements repeated on the 3 primary advertising channels. So quite quick.
Wonderful. Okay, last question for the day. At a time, how many sensors can be handled? Data transfer point of view, is there any limitations?
No, there's no
yeah.
limitation. Oh, sorry, go ahead. Go ahead.
Sorry,
go ahead.
I was thinking this was talking about the Ion 100 BLE beacon side of things, for how many sensors can connect for the beacon. Yeah. So we have 3 I2C slaves and 4 ADC channels. So we have several use cases already that are using 3 or 4 sensors. So it really depends more on getting all that data on the payload rather than a limitation of how many sensors we can talk to. Sorry, Gianpaolo, go on.
Yeah, and I just want to add, also from the network standpoint, there is no limitation on the data transfer, right? And you can pack as many sensors as the angle of coverage will fit in.
Wonderful. Okay, that's all the questions for today. Thank you for all your time joining the session today. Please feel free to contact the team if you have any more questions. I'll be emailing the slides, the recording, and also the team contact again afterwards. And if you happen to be at Sensors Converge, please come and meet us for a real life demo. The in-play booth is 707 and Energis booth is at 950.
June 25th
again,
and 26th in Santa Clara.
Absolutely. That's in Santa Clara, Sensors Converge event. We hope to see you there. And again, thank you to our speakers for their valuable insights and to you, our audience, for your engaging questions and participation. Thank you. I hope you have a great day.
Thank you for everybody.
Bye-bye, guys.
Bye-bye.